Welcome everyone to the second webinar of the 2026 season. This webinar is focused on weather and Gulfstream and is a more tactically focused continuation of the Gulfstream Weather and Tactics webinar that was held last May. If you didn't watch that session, you can find it on the Bermuda Race YouTube channel. Tonight's panelists are Frank Bohlen and Chelsea Freas. Chelsea is a lifelong sailor and meteorologist from the University of Miami. Chelsea's career includes weather forecasting for industrial marine operators, global passage makers, Grand Prix race teams, and the U.S. national team. Chelsea is the founder of Sea Tactics, and she will be the expert meteorologist on our new Gulfstream Daily show during the race. Chelsea is also hosting a Newport Bermuda Strategy Lab starting this Saturday, where you can sign up on our website at seatactics.com. Frank Bohlen is a Gulfstream expert who needs no introduction, but a little introduction is still merited for those who are new. He's an emeritus professor of marine science at the University of Connecticut, specializing in physical oceanography. He's a longtime student of the Gulfstream and has been experiencing it personally for over 50 years. This race will be Frank's 23rd Newport Bermuda race, so he has seen a thing or two in the Gulfstream. Frank is a Cruising Club of America member, long-standing member of the Bermuda Race Organizing Committee, and is the consultant to nearly every East Coast race that touches the Gulfstream. Before I turn it over to Frank, I want to mention that there will be Q&A at the end of both presentations, or at the end of all of the presentations. If you have questions, post them in the chat, and we'll pick them up at the end. All right, with that, Frank, I'll turn it over to you, and let's hear about the Gulfstream.
Thanks, Andrew. Well, I'm hoping that all of you out there have had some time to take a look at the first webinar where we covered some of the fundamentals of the stream. I think that we continue to learn about those fundamentals as we go. So it's really worth your while to get some study in before the race, because it's been said that races are lost on the water. And that right now, most of you that are getting ready for this race know how much work goes in before the race. And the Gulfstream and weather as subjects are no different than your efforts put into sails, into hull. You're inspecting the rudder, you're inspecting the keel. You put some time into understanding what the Gulfstream is and what it may be when you're going down there, what it means to weather. Chelsea will talk about that in a minute. But also to remember that this kind of study is important to you and to your navigators, to you as navigators, whether you have a consultant or not. So let's get back and take a look at what we're dealing with. In general, the Gulfstream is part of the course to Bermuda. The course to Bermuda consists of generally three pieces. That's the continental shelf, the guy up on top, that con shelf feature. Okay. The Gulfstream itself, and then a region from the stream, south of the stream, down to Bermuda. The stream here is about 60 miles wide, 100 kilometers in general. And we'll be talking in detail about that. But you can also have some interesting stream effects north and south of the stream. Generally on the shelf, the continental shelf, the stream influence is relatively minor. But there can be warm core rings that are shed up that way that may influence the course down. Chelsea will talk a little bit about the weather in that area. Because it tends to be quite different than the weather we experience as we get down the stream and south. To refresh our memories from the fundamental, the Gulfstream is a portion of the large North Atlantic gyre. So here's our Gulfstream, the western edge over here of this large clockwise gyre or circular pattern. It's in general wind driven. And it's important to remember that wind blowing over the water can produce, as in this speed of the wind, okay, can produce some speed of the water, roughly about 3%. So if you have 30 knots of wind, you'll get for the speed in the water something on the order of a knot. So for all of the talk about what the stream is or isn't, it depends very much what the wind is when you're out there. In general, we'll be seeing currents that range from about 3 to 4 to 5 knots, but sometimes can be greater, higher if the wind is there. Okay. The wind blowing on the water, northern hemisphere, tends to produce flows to the right of the wind. And as a result, the waters tend to pile up in the middle of the Sargasso Sea. Pile is relative, of course. We're talking about possibly a meter in elevation. But this change in elevation is important when it comes to currents, as we'll see. We're going to take advantage of that when we measure the altimetry. Produces something of this mound down here. The old story, as we've known for years, we've been sailing uphill down to Bermuda, and you have. But it's about a meter and 100 kilometers, which is not a heck of a lot of a hill. Water temperatures are important. Possibly the easiest way to know when you're in the stream is to take a look at the water temperatures. This is a section that was taken at 36 North in the late fall. So your shelf temperatures up in here were about 10 degrees centigrade, something on the order of 50 degrees Fahrenheit. And you can see going out here, it got up to 24, 25. Here is the Gulf Stream right here, proper, fairly narrow, as I said, typically on the order of 60 miles wide. But you can believe as you're coming down from 50-degree water and you're getting now into something on the order of 70 to 80-degree water as you're moving into the sea, you'll notice a change in water temperatures. Best way to know when you're there. Salinities are also important because the temperature and salinity combination affects water column densities, and water column densities produce flows. So the stream flow total is the result of wind-driven, primarily wind-driven, but also affected by the temperature salinity density contrast. The temperature. Let's take a look at temperature. Here's a satellite image of the stream from the Rutgers site. This is one of my favorites. Sorry. It's the laptop pad that makes the active here. Sorry about that. The source for Rutgers images is on the links that's on the website under resources. You're going to hear about that as we go here. So here's sort of a fundamental picture of the stream. You have the main body of the stream. That's this brighter yellow pattern. And you can see the temperatures are up around 22 to 25 degrees centigrade when we're getting in here. This was a February profile. So here's your temperatures on the shelf with something like 4 degrees centigrade, 40 degrees Fahrenheit. Okay. The stream in general flows off to the northeast. But of course, you can have meanders where the flow is really going northwest. Around here, we're going northerly, and then back to the southeast, and so forth, on towards Europe, the main body of the stream, with meanders and on occasion rings. In this case, there's a warm core ring. And the warm core rings tend to be clockwise features, sitting in here, rotating clockwise. The rule of thumb is if the warm water is on your right hand, your right shoulder, and you're looking downstream, okay? So you got a clockwise feature. This guy is going to drift to the west here. So you might be watching if we're leaving in late in February. This is the 16th, leaving late in February. The ring might get down in the vicinity of the rum line and might be influencing the currents along the rum line, giving you a foul current on the rum line heading for Bermuda. So that's the game we're playing, looking at the structure of the stream, the presence or absence of rings, their position, and their probable motion. So we began in early April. And this is sort of an interesting sequence, if you follow me now. Again, all of these color satellite images are from the Rutgers site. Now, the new Rutgers site is not quite as good as the old Rutgers site. There's a long story in that. If you'll note up on top, it says no cloud correction applied. So you have to be careful in reading these because on occasion, clouds can change the patterns. As you see, the clouds certainly, the white is cloud, but there could be wispy cloud that may be affecting these patterns. If the cloud correction was applied, this guy might be bright red all the way around, not so much with thrown yellows. So be careful in reading these. But here we are, rum line, the black line coming down, fairly typically just about 250 to 300 miles southeast of Newport, heading towards Bermuda. You'll run into the edge of the stream. And here you have the beginning of a meander, and it's quite a dive off at the end here, okay? The third, here we go. The sixth, Holy Christmas. Third, sixth, that meanders moved over this way and deepened. The currents now are crossing the stream back here. They were crossing the stream more or less at right angles, You get into this next guy, and it's really coming from the southwest to the northeast, to the north, or south to north even. So that may affect your optimum route significantly. 3 days change. Another 5 days, the meander has continued to move towards England, which is what we like to see, a fairly nice progression. You're down near the trough right now. Here you are the 15th, not much change, but a little bit. You can see that it has moved off to the northeast. And here you are on the 20th, quite a mound, okay? So it looked like that meander migrated fairly regularly. Some of you will know that, will remember that of late, the meanders have been behaving somewhat erratically. They don't always meander to the northeast. On occasion, they've been backing up, retrograde, heading towards Hatteras, and then breaking off, forming rings. This one looks like it's doing okay, but hang on, we're at the 20th. Here's the 23rd, 23rd, it's gone. The whole thing just sort of flattened right out. So you're doing this sequencing to get an idea of the characteristics of your dance partner. How rapidly will this thing change? Might it change? Why for? Because very likely you're going to run into a situation like this. From the 23rd to the 26th to only recently, early May, the whole stream area was covered with cloud. We weren't getting a look at it. If it can happen, it will happen. And if it will happen when, it might well happen the week before the start of the Bermuda Race. So you got to get an idea what things might be doing and then have some sense of how they might change over the course of a week, possibly, over the course of a week. And we've just seen in 3 or 4 days, we can get substantial changes. Okay, we're lucky. On the 2nd of May, some of that cloud disappeared, and here we're back. Okay, and here we are again. A meander starting to form up in the vicinity of the rum line, and looks like it's actually deepened out in a day, 2 days. Okay, so here we are in the 4th. These are the kind of studies the navigator is doing. Now, you're looking at this, the 4th today. Today is the 4th, okay? So that's the conditions we're seeing today, more or less. And we're now going to take a look and see what some of our models do, because very often you'll want to use these files that we're looking at here, these satellite images, are not in grid format to incorporate into optimum routing programs like Expedition. So let's take a look at some of the models. The first model that I like to play with, the first model I will always go to, is the real-time altimetry model. This is a model based on the measurement of sea surface elevations, and it's an all-weather observation. There's about a 2-day delay, so I put up the 4th here, and we're going to compare it to the 2nd, okay? So here you are on the 4th, and the stream is right in here, and there is your meander. Doesn't look quite as bright on here as it did on the satellite imagery, the IR imagery. Remember, these are current patterns, not temperature patterns, so there could be some slight differences. Of significance to us, though, is the presence of this ring. This is a cold core ring sitting down here. And if we looked at this, we're not tonight going to go back over a month's worth of altimetry data, but if we did, we'd find that this has moved very little for the last month or so, it's almost been stationary. In fact, it's had some companion. It had a companion in this guy up in here. Okay, both of them probably being influenced by the main body of the Gulf Stream, being entrained by the Gulf Stream, so that rather than drifting to the west as they're forecast to do, they're either staying put or drifting slightly to the east. Okay, but this guy is right on the rum line, as you can see. Now keep an eye on that. Mind you, now Bohlen at least has a lot of confidence in this model, so he would be navigating to either get on the far side of this. That's quite a jump. This is 5 degrees here, latitude. Okay, so that's quite a jump. That's 60, 80 miles out here to get on the other side of this. Or he might be trying, the currents are weaker on the east side, but as I've said before, I'm reluctant to get to the east, but I may be forced to the east. We'll see. We'll see between now and June 19. Okay, compare that with this guy here. It looks like there's pretty good agreement. This is the 2nd of May, I just showed you. But here you are, and there is the meander that you were seeing in the altimetry. That's it right here. Okay, right in here. One thing that's not quite so clear on the IR is the cold core ring, and that's showing up. The suggestion is that it's down here, but you can see this white is cloud interference, and there could be some, you'd be suspect of that if this is all you had. But this is probably the cold core ring right down in here. We'll also note that there is very little in the way of other rings further to the south. I've lost my cursor here. There we go. There's very little interference down here, foul currents down here. Once you get clear of this ring, it looks like clear sailing down to Bermuda. Okay. Now, another model. This is the Mercator or Mercator model that we can find on the Copernicus Marine Data Store site, which is in the links. And here we are again. And this is now the 2nd of May, and it's fairly good agreement. This is in grid format, so you can bring this into expedition. I don't see much in the way of ring down here, although there's a suggestion of it. I use this site on occasion. I think it's very interesting. I know some really count on this model more than they count on the NOAA model, which we'll see in a minute. But one thing that's interesting here, this is the 2nd, and this is the 4th. Same, okay. This is their prediction of this, and the 4th that you just saw before. That you just saw before, from temperature and from the altimetry, doesn't show quite much of a dip in the meander pattern. So there's a question here: is this for real or not? This again may be the ring. You can see it's fairly close to the stream main body of the stream, so it's likely to be entrained. Okay, let's go over to our friend here. This is the Global Real-Time Ocean Forecast System from NOAA, which many of us use as the current model in expedition. It's a little hard to tell what you're looking at here. This guy has quite a break-off. Fairly straight in the way of the main body of the stream, and then to the east, quite a dip in the pattern. You'll see that better here. This is it showing up on expedition, and you can see right away. I would be suspect of the whole thing. I would be looking at my pattern from the altimetry, and it doesn't seem to show quite that much of a dip in the main body of the stream. And it shows this, here's your cold core ring in the real-time model, real-time ocean forecast system model, but it's quite clear of the rum line. You can see that they're believing all of this because they're providing, this is now an optimum route for blue skies, the boat I'm sailing on, running the GFS weather against this pattern. And you can see the optimum route is primarily weather driven. They're getting you in the main body of the stream up in here, but they don't care about this. They're really bringing you over closer to it. The alternative would say you might be suspect in here. So these are all the sorts of questions that you'd be asking as you go along through this. Which model to believe? All the time comparing model results, if at all possible, to direct observations like the Rutgers site. You want to use a variety of resources. Consider the scales of variability, what kind of a change is going to be over what area and what that might mean to you, realizing what the resolution of the numerical models of both weather and Gulf Stream are. It's not a 50-foot patch of ocean. It tends to be 10 to 20 kilometers. And what kind of accuracy? It depends. Some of this wind against the current conditions might affect sea state, for example, and your boat might not handle a really foul sea state very well at all. Perception limitations used to be something we'd really worried about, but Starlink has changed an awful lot of that for most of us. And then there's the matter of sensory overload. When you get offshore, I would recommend having one or two sources of information that you're familiar with. You've lived with GFS for a few months and you've gained some confidence in it, some sense of when it's right and when it's wrong. And when you get out there, even though you can get 3 or 4 other models of weather, I guarantee you it won't settle your stomach anymore by working with 5 models if you know one well. So pay attention to sensory overload. It can be very fatiguing on a race. Okay, the links that are on the website under resources, you want to just get a look through there. We try to keep those up to date as much as possible, but it's a continuing exercise because, as you know, websites have been known to change without notice. Preparation's everything. Prior planning prevents poor performance. There's a few other words in there. Okay, but time spent before the race it's a very, very good investment. And the more time you can spend with the different resources, the better off. So then if you talk to some of the navigators, they've been at this for a long time, going back in the archives, looking at weather and past races, get a sense of what's going on from the weather standpoint and from the flow standpoint, Gulf Stream and the area south of the stream. Thanks very much.
All right. Hi, everyone. Thanks for joining tonight. And that was a great presentation from Frank. As usual, I'm always learning things every time I hear him talk. So I couldn't agree more in terms of making sure that you are watching and paying attention to the patterns in the stream early on. I know I have several clients that have been asking questions about the stream and looking at it, as early as April, so weeks ago. I am going to give you a much shorter version here of some pre-race weather tips. As you guys know, the weather can't really be watched in the same way that the Gulf Stream is this far in advance, but there are a few things that we can do. So I'm going to walk you through those. And I also want to mention, if you haven't gone back and watched the first webinar, the one that we did last year with Stan Honey, there's a wealth of information in that one, and that's really kind of the starting place for all of this. And this next few minutes is sort of an add-on. So really make sure you go back and watch that. This is going to be really kind of a quick update on what we can do this year and what's new for this year. So what can you do this early on for weather? Really, it's too early for real weather prediction. So we would be looking at historical weather conditions and patterns. There are a few different ways of doing that. You can get previous historical grid files. So you can have that either be like historical GFS models, Euro models, or what I recommend is going back and getting what's called a reanalysis grid file, which you can get, which is essentially better than a weather model. It's a combination of what the weather models were at the time, along with all of the observations that are happening all around the world. So it's the best guess of what the atmosphere really looked like at that time. So it's really good for going back and looking at historical conditions. And so there are grid file locations for that you can download that. One, I believe, is on our website, the Bermuda Race website. It's somewhere in there, but if you can't find it there, you can also go to my website, and in my free weather resource library, I have links to those grids there. Once you have those historical grids, you can do some mock routing. So you can pick a weather pattern that looks similar to the weather pattern we're in now. So something, or that we will be in June. Go back to previous Junes. Once we get into the early weeks of June, we can start to see how often fronts are coming off the coast and what the pattern looks like, specifically, more at the upper levels at 500 millibars or so. And we can use those grid files to then basically predict, okay, we could have a race that looks like this. It's not going to give you specifics, but you can plan for some scenarios. And then just going through the exercise of mock routing. What is your routing flow? I like what Frank said is, what grid files, what models are you going to use? How are we going to narrow this down? And just going through your routing flow for both pre-race and during the race. Pre-race, you're going to have way more time, way more energy to look at the routing. Once you get on the boat, very different. So that's why I always emphasize that we are creating a plan in the days leading up to the race, so that during the race, you're hopefully not having to make too many difficult decisions. You already have an if-then playbook of, if this happens, we're going to do this. If this happens, that's going to happen. So it reduces some of that decision fatigue during the race. So in a few weeks, we can start really analyzing the pattern. It's still, we can look now, but it's a little early in early May. Things are going to change a lot between May and June in terms of the weather pattern. But what I can tell you is that now, even just now for early May, we are in a relatively active weather pattern for this time of year. You guys may have known this depending on where you're located, but there have been quite a few like bigger lows and fronts coming off. Not unprecedented, but it is just a little bit more on the active side for early May. We'll have to see if this continues going into June. You can also go and look at past race data and tracking data and check out the weather patterns that were happening there. What were boats doing? Were they going east of Rumline, west of Rumline? You can grab the old Gulf Stream grids and Gulf Stream analysis and figure out what the Gulf Stream looked like. So there's a bunch of different pieces you can do there. But again, you don't have to go too deep into this because we're going to start getting an idea of what all this looks like coming up. In terms of what's new this year, what I would add on from what we talked about last year in the webinar would be the introduction of AI models. And there's been just a ton of questions about them and whether I'm using them, whether people should use them. So I thought I'd just kind of give you my snapshot of where I see the AI models to be. Personally, I'm not using them a lot because I'm doing really specific high resolution type forecast a lot. And so I'm not using them a ton. But for the longer range, they are starting to show some skill. And if you're looking at the weather pattern in closer detail coming up to the race, you may add that in to your arsenal. And if this is overwhelming, you don't have to do it at all. And I think you're going to be just fine using GFS, ECMWF, the core global models. You'll be fine. But if you are, maybe a more experienced racer and, you're kind of into all of the weather model stuff, we could add this in. So basically, what are they? They're data-driven models that are trained on that reanalysis, that Era 5 data that I was just telling you about, those grid files from Copernicus. So basically, it's just trained on those patterns. Instead of solving the complex physics equations, it is much faster for them to actually just understand the weather patterns. And so there's one in particular, the Google model GraphCast, that it has shown to have improved skill in comparison to the ECMWF in the longer range. So in the 4 to 10 day range. So not right up and not during the race, not right before the race, but longer range. It's showing fairly good skill in where the larger weather systems are. Okay, I'll talk about that in a second. The ECMWF AI is supposed to be pretty good from what I've read and understood and seen, that it's kind of average. And then the GFS AI is not quite as good as the others from what I've seen. And then where they excel. So like I said, this is going to be something you're going to use for the medium range, 4 to 10 days. I would almost argue that's almost long range in terms of sailboat racing. Large scale atmospheric patterns. So where the highs are, lows are, fronts, and big troughs and ridges, it's going to get that broad brush pattern a little bit more correct and have a little bit more consistency than maybe the ECMWF or the GFS. We think, right? This has only been around a couple of years. We don't have a ton of data, but GraphCast from Google is showing to be decent, which I think the platform that you can get that is through Weather Next. So I'll have to follow up and find the link for that because I haven't found the link yet to send out, but we can work on getting that for you. So anyways, good at large scale patterns, medium range, and then where they are not so great, as I mentioned, small scale local effects, places where you have sharp gradients, sharp fronts, convective systems. So if it's something where there's a lot of storm cells around, it's not going to capture that really accurately at all, and anything in the short term. So within the next couple of days, which is why I tend to not be using it quite a lot, because I'm usually doing a lot of short-term forecasting. So they may be more accurate overall in the medium range, but less reliable at a specific point. Partly of what I'm trying to say is I wouldn't waste too much of my time looking at this, especially in the short term or right before the race. The best plan is going to be kind of a hybrid plan where maybe you look at the AI models for the long to medium range and the large scale pattern, and you compare it to the ECMWF and the GFS. I have noticed that those AI models have less run-to-run discrepancies, or like if you've ever seen the models ping pong, especially this time of year, where they're showing a big storm and then the next run comes in and there's no storm, and then the next run comes in and there's a big storm, and it's ping ponging back and forth. These models don't do that as much. So it's going to give you that smoother idea of like, okay, well, over the long term, this has been showing that there's no storm, so we're going to lean that direction. So it may help give you kind of that third opinion between GFS, ECMWF, and help make some of those thoughts a little clearer. Then you'd want to use just our regular kind of deterministic traditional models, the ECMWF, the GFS, for your routing and your specific scenario guidance. And then obviously where possible, you want to use high resolution models for your detailed routing. Okay. So don't be trying to add in too much AI model stuff, on your last couple days before the race. So what does this actually mean? More models definitely does not mean easier decisions. And Frank alluded to that as well. Same thing with the Gulf Stream. Adding in more models doesn't reduce the uncertainty or make any interpretation easier. So if anything, there's just more information to process, which I know can be a lot. So really what I want to emphasize focusing on, and where you're going to gain your advantage, is understanding some of the model differences, recognizing those patterns early. So this comes from, like Frank mentioned, starting to watch some of the patterns between the European model and the GFS model, in terms of which one is verifying, if one is showing a big storm coming off the East Coast, which one is actually becoming more accurate. Because sometimes it will show a storm, just doesn't come to pass. So, and I've already seen it happen in the last few weeks. So my delivery clients coming up and down the coast, starting to see some of these models have definitely some bias towards a couple of them, depending on where you are. And then building a plan before the race week. Obviously, like I mentioned, we want to help build your plan out so that when you get to the race week, you know exactly what the features are that you are looking at, and you don't get bogged down in models that are showing extraneous things that we don't think are actually going to happen. Okay. This whole process is what we're working through in a program I'm starting up called the Bermuda Strategy Lab. So this is going to be your weekly sessions from now, starting this Saturday, all the way through the start of the race. Every Saturday, we're going to meet bright and early, 8 a.m. We're going to go through a bunch of different things, some climatology. We're going to talk through these model patterns, how the weather pattern is starting to shape up closer to the race. We will watch the Gulf Stream. So some of those things that Frank was pointing out in terms of meanders and rings, we're going to start really tracking that starting this week. There's also some really cool guest appearances that I have coming. So I have Kevin Rosa from Current Lab, who's going to join me. I'm going to do one whole session on race climatology. Kevin's going to do a whole session on Gulf Stream resources, altimetry, deeper dive. And then we're going to have a whole session on navigator resources. If you're a new navigator or just a navigator that wants to dive in a little deeper into the weather world, we're going to have a whole session for that. And then each week we're going to talk through these patterns, right? So I want to invite you guys to come have your coffee with me bright and early Saturday mornings. Like I said, you can have 2 people per boat join. So it's kind of for the team. So typically like the navigator and then one other person will come, and you can have replay access. That'll be going on again for 6 weeks. The link for that is going to be in the description of the YouTube video below, but you can also find it on my website, c-tactics.com, and then also on the Bermuda Race site. So I would love to see you guys there. And if you have more questions, I am here to answer them now, or you can ask me another time. But thanks for having me here tonight.
Thank you, Chelsea and Frank. Thank you guys for taking the time to be with us tonight. And thanks to all the competitors out there tuning in. I also want to offer a quick shout out to Kate Summers, who's pulling the strings in the background, making sure these media tools are more valuable and a little bit more enhanced each time we try them. So thanks, Kate, for all your hard work and innovations. I'll tell you, the talk about the Gulf Stream is really comforting right now, because if you're in New England, it's cold and windy up here. So I'm looking forward to getting into some warmer water. I'm looking for questions in the chat. We'll see what pops up. I have a couple myself. And I guess it's to both of you because it deals with models generally. Are you seeing any trends in the models in terms of their improvement? I mean, we hope that there are people working on these models and enhancing them as time goes on. Do you see trends that give us confidence that these models are getting better and better and better as we trend towards reality, over the next 4, 5, 6 days, both weather and currents? What are you guys seeing?
Well, I'd say overall the models are getting better. That we can certainly look at some of I can blame the weather models that I'm not working on every day, and Chelsea can blame the Gulf Stream models. I thought that it was really an interesting result of Chelsea's comments about the AI models, about when they work better and when they don't work quite so well, because it really it reinforces something that we often have in coursework. When you talk about what the flows are, whether it's atmospheric or oceanographic flows, they are turbulent. And turbulence is, from a mathematical standpoint, very difficult to solve perfectly, because if we wrote out the equations, there's a whole series of terms that just keeps going and going. And what we tend to do in the interest of computational time and cost is to truncate the analyses. And that's the old story about the butterfly in Tennessee causing the tornado in Kentucky. When you get down to look at what the AI models can handle right now, realizing that for in a large part, most of the models that we see, most of the algorithms that we see, are really pattern recognition schemes. And so when you get down to the finest scales in time and space, it's very difficult to absolutely resolve that. Now, that's one of the improvements that has been going on year by year. The resolution, the spatial resolution, the temporal resolution of all these models has been improving. I don't know what the latest is, but the HRRR has a 3-kilometer resolution kind of a thing, which is like 1.5 miles or so. That's pretty good against the GFS that might be running 25 kilometers and the Euro models that might be on the order of 30. And here you and I are carrying about a 50-foot patch of ocean. Of course, both the Europeans and the US tend to run these large-scale models at higher resolution. They just don't broadcast the results for us. But I think overall, both the oceanographic and the atmospheric models have been improving over the years, over the last 5 years.
Yeah, I would agree. I think it's a slower progression over time, especially as they start to put a little bit more resources into the brand new models like the AI or, the new version of the HRRR. But in general, there's improvements. And I think a lot more effort is put into the weather models than some of the oceanographic models, which is a real shame. I think that they should be updating the oceanographic models much more.
Yeah. Well, one thing that we, again, have said this before, to keep in mind that the oceanographic models, for the most part, not entirely, but for the most part, are designed to provide information on the heat flux from the equator to the pole. And you don't need kilometer resolution to do that. Now we come back and we say, but we need it for sea state and we need it for the current set and drift. It's again a matter of the audience. You look at the kind of weather information that we have on land relative to the kind of weather information and data gathering that we have at sea. And it's the same sort of thing and worse with the oceanographic stuff.
Yep, very good. Good question just came in. I'll read it to you guys. With respect to the Gulf Stream, are there eras of relative stability and ease of prediction versus eras of instability and difficulty of prediction? And if so, what are we in right now? I think the question's a little bit about if there's a big forcing function, are the models better or are they worse than if there's relatively modest or very little forcing function?
I guess it's hard to say, but I think, well, first of all, the computational capabilities have certainly improved significantly since we started playing this game. You think about what you had for a computer in 1970 against what you have in a computer today. One of the reasons that we're a little bit behind in some of the European effort, relative to some of the European effort, is the amount of time the European cooperative put into the development of big computers. And then Chelsea has it quite right. You look around down there right now, and staffing is in many areas thin. So you put the two together, we may be in a time, for a variety of reasons that are beyond hardware or oceanographic understanding, the understanding of the turbulent flow, that leads to some instability in the modeling. Hard to know. It's a difficult question to answer.
Sure. Another one came in. Once underway, how often is it useful to download latest models and reconsider your plan, and how often might it be counterproductive?
Yeah, that's a great question. Because there are instances where, you might be nearing a front or nearing a particular, what I call a critical decision point, that you want to download every single weather update that comes in, which could be every couple hours if you're using HRRR, or maybe it's every 6 hours if you're on GFS. And 12 hours if you're on Euro. So I would say if you're in a very stable pattern, and this is where it comes down to watching how the pattern's evolving. But if you're just in a stable high pressure or something, and it's been high confidence in that forecast, you probably don't need to download every single run, every 6 hours. Although there are probably navigators that will anyway. But definitely if it's one of those critical decision points in the race, or something that we didn't quite have high confidence on before you left the dock, and then now you're a day or two into the race and you need to see whether that's actually going to be true, then yeah, you would want to download. And in terms of reconsidering your route plan, from my experience racing and navigating, is that I tend to stick very close to the plan that I made before I left on the race. Very rarely does it ever pay off to completely change your plan in the middle of the race. So even if things don't seem to be going in the way that exactly the way you thought, or it's a little deviation, you're like, oh, this is different. Okay, what's happening here? Don't throw out the forecast with the bathwater. Stick to your original plan, see what happens. And, ideally before the race, we're thinking about what those alternative scenarios are so that you're prepared for them. And you're like, oh, this is one of the alternatives that could have happened. Now we know what to do. So.
Yeah, a couple of things come to mind on that. It seems to me that there are two considerations. We're worried about a front coming through, or with a low riding along a front that might be coming by us, to give us a gale or storm conditions. You can really only get that information, as Chelsea just said, 3 or 4 times a day. It's important to look outside, and you're supplementing what's going on by watching that cloud. Chelsea talked about that the other night in weather stuff. So it depends on what the problem is. If there is a problem, catastrophic, you got to really be careful. Then you come down to the fact that most of us are sailing 5-knot sailboats. Second subject, we're sailing 5 or 7-knot sailboats. We're not sailing a Comanche. So when we get ourselves, if we went out that 60 miles that I showed on the altimetry, that's a long way off the track. And at 5 knots, 7 knots to get back to Bermuda, you've added significantly to the length of that string. So there's only so much you can do once you play the cards that you're dealt. And then you say, well, I'd really rather be east of the rum line, but I'm west of the. You can't get over there in a big hurry. There was one area I just was remembering the last Bermuda race. As I've said before, I'm very reluctant to get east of the rum line on my 5 to 7 knot sailboat, because 9 times out of 10, I've got to beat my way back to Bermuda. When I get down to Bermuda, I've got a southwesterly, sort of 9 times out of 10 over the years. So at 5 knots, coming back 5 miles, 10 miles is an hour. And if you take a look at the first through the 8th boats in many of our classes, that's a lot of time. That's a lot of time. And it can be minutes in difference between the first and third boat. So you really have to take into consideration all of that as you're getting down there, how far you're going to get sucked out, even though you're waiting for that wind shift that may come or may never come, that sort of thing. It depends on, the answer to the question, it sort of depends on the condition.
Right. Very good. A question related to that, the one about eras of stability or instability. We are certainly in an era right now of affordable high bandwidth access. Mm-hmm. And if I reflect back on where we were, say, 3 race cycles ago, most people were still getting data with a very, very thin dial-up straw. And so we only had certain resources available to us.
Right.
With the advent of Starlink and almost free high bandwidth data, what resources are available to the navigator that you would want to take advantage of that weren't available, 3 races ago?
I'm going to say for Chelsea, she said she loves windy.
Yeah, I was going to say websites. I mean, that's the big thing that you could never get before, is you couldn't get on any kind of a complex website. And now if you want to pull up windy, you can pull up windy. If you want to pull up interactive sites, on the Gulfstream, you can. So that's the biggest change for me, is that, you know,
Absolutely.
the grid files are still there, the models are still there, but there's different ways of viewing it. And there might be
Mhm.
easier ways of getting the information you need if you can pull it up on a website.
I'll add one other thing. You're wrong about not being able to get it several races ago. We could get it several races ago if you could pay for it.
Yeah.
We had a
You mentioned affordable.
we had a Thales Certus system, an Iridium system, and you pull down Windy, and it's hellish bandwidth, and every bit costs you $1. And all of a sudden, you're out 25 megs, and and now they're charging you $9 or whatever it is for the next megs or so. All of a sudden, you come back and you give the skipper at the end of the race a bill for $6,000.
I guess it proves the value of the data. Or as a
really
navigator, you better be sure you're getting the right data for $6,000.
Right.
Another question came up. I'm a Great Lakes sailor, familiar with expedition, and we'll be doing the race this year. What additional gribs would you be loading for route optimization?
Additional gribs. So I'm guessing that
Things you
means
might
kind of
not,
beyond
things you might
just
not get a hold of or need when you're in the Great Lakes, I guess is the question.
Christ,
yeah.
everything.
I would say, I mean, I'm going to be definitely using HRRR. The GFS and the Euro are kind of the big three. Those are the main ones, but there are a lot of additional gribs out there, like I mentioned, and Frank mentioned this, you're going to get sensory overload if you're looking at 6 models. So familiarize yourself with the main ones. In my opinion, don't bog yourself down with too many extraneous ones. That's my 2 cents.
Second, absolutely.
Yeah.
What about human enhanced models? I remember many times hearing discussions about the weather, especially from the NOAA expert that we often bring on for the skippers meeting. And a lot of the weather they talk about is informed by the experts, who basically take the analysis and tweak it based on their experience. We couldn't really use this during the race, right? Because it has to be publicly available data. But prior to the race, we might be able to get our hands pay for human enhanced gribs. What options are there for that?
Well, there are human enhanced gribs, weather gribs that are publicly available from NOAA. So the NDFD is the National Digital Forecast Database model. So it's basically the human enhanced version of one of the gribs. I think it's a lot of times based on the GFS. But the issue with that one is that I find it not so useful, just because it tends to be really coarse resolution. It's like, I don't quote me on what it is, but it's not high resolution at all. It's like 50 kilometers or 25 kilometers or something. You get higher resolution with a GFS or a Euro, and it's very broad brushed, and it's not quite as good as, like, you're better off in my mind using the HRRR than that human enhanced model. At least over the ocean. It might be different over land or something. And the other thing I was going to say is that for a while we have been using, I'm sure several people have also used this, human enhanced Gulfstream model data, where we start with the altimetry grib, and then we know that this eddy is moving, let's say, to the west at 3 knots, and we manually propagate it in that model, and then proprietarily, give that for the race. So we are doing something like that with Current Lab this year.
Great. I don't see any other questions in the chat, and I've pretty much exhausted mine. Do you guys have any questions for each other, or have you pretty much covered it?
No, very clear.
Yeah.
Great.
Unfortunately, Saturday morning is a time in the next few weeks when people are going to be going out sailing if they can.
I know. That was the whole point in doing it 8 a.m. was to get people to log on with their coffee before they go out sailing. But there will be people that miss it, and that's why you can watch the recording. But yeah, I agree. It was hard to find a time.
Always. That's terrific.
Well, Chelsea, thanks for offering that service. And Frank, thank you for your time tonight. And we look forward to getting more information from you guys as we get closer to the race. And Chelsea, we look forward to seeing you on the Gulfstream Daily too.
Yep. Start.
Yep.
I'm going to start the Gulfstream notes probably in the next couple of weeks.
And competitors can find those on the website, propagating week after week, right?
On the resources, right?
Yeah, great.
Can't wait to read those.
Fantastic. Thanks, everybody. Thanks for all who attend, and we will catch you on the next one.
Thank you. Bye.